If you like this video, at the end click on like button, and for more updates do subscribe to my channel. Block of weight W1 is equal to 890 newtons, rests on a horizontal surface and supports on top of another block of weight 222.5 newtons, that is the second block. The second block is attached to a vertical wall by the inclined string AB. So here we need to calculate the horizontal force which is applied to the block 1 that will be necessary to cause slipping to impede. And the coefficient of friction for all contact surfaces is given as 0.3. For solving the problem, we need to draw free body diagram and apply equations of equilibrium. This is the common procedure adopted for any kind of problem, generally in friction. So here, as there are two blocks, you may ask me which block we have to start with. So when we consider these two, the force is applied to the block 1. Because of that, it will tend to move in positive x direction. The impending motion is there for block 1 first. You need to start with a free body diagram of block 1. Let us start the solution. First, let us find the angle in the given triangle. So this is the given triangle, making an inclination with the horizontal as theta. So then this angle will be also theta, right? Alternate angle. So let us find the angle from this triangle. Tan theta is nothing but opposite side by adjacent side. So opposite side is 3 for this triangle and adjacent side is 4. From this, theta is equal to tan inverse 3 divided by 4, which is nothing but 36.86. Now let us start the solution for this problem by starting with a free body diagram of block 1. So remove all the contact surfaces and draw the block 1 separately. Represent the given force P like this. So whenever we are drawing free body diagram, the first thing you need to represent is weight. Always weight acts vertically downwards. So represent the weight. Weight acts vertically downwards through center of gravity, and the weight of the block 1 is given as 890 newtons. Now you need to observe the block is not able to move in which direction. So here this block is not able to move in downward direction. So as it is not able to move in downward direction, in the opposite direction perpendicular to surface represent reaction. So I am considering it as N1. So here if you observe, this block is not able to move in another direction, that is in upward direction. So you have to represent a reaction in the opposite direction. So this is the reaction. So that is also acting vertical downwards as it is not able to move in upward direction. So I'm considering it as N2. So here this block is in contact with two surfaces. The lower surface is in contact with the horizontal floor and the upper surface is in contact with the another block. So when P is applied along horizontal direction, so it may tend to move in positive x direction. So you need to represent friction in the opposite direction. So that is F1 in this direction and F2 in this direction. As coefficient of friction is given common, so it is equal to mu n1. I am considering it with common letter mu. So F2 is equal to mu n2. Let us consider the free body diagram for block 2 also. Similarly, as we done for free body diagram for block 1, so remove all the contact surfaces and draw the block separately. The first thing you need to represent is weight. Always weight acts vertically downwards. So represent a weight W2, which is equal to 222.5 newtons vertically downwards. And there is a string, right? So along the string you need to represent tensile force, and always the tensile force acts away from the object. So let S be the tensile force in the string. As it is string, I am considering S here. You can consider T also. And we have calculated theta, right? So that is with the horizontal. So let us keep it as theta here. And if you observe, this block is not able to move in downward direction. As it is not able to move in downward direction, so we will represent a reaction in the opposite direction perpendicular to surface. So a reaction in opposite to, it will become N2. According to Newton's third law, these two forces should be equal. Why? Because if these two forces are equal in magnitude, opposite in direction, and collinear in action, then only equilibrium will exist. So which is nothing but Newton's third law. For every action there is an equal and opposite reaction. For this N2, this will be the reaction. If this is action, this is reaction. If this is reaction, this is action, right? So this is N2 like that. So here the force of friction also follows the Newton's third law. So here a frictional force is in left hand side direction. So opposite to that one, here we need to represent in this direction so that the system remains in equilibrium. So F2 is equal to mu N2. So this is the free body diagram for the block 2. S can be resolved into two components, one along horizontal direction, one along vertical direction. So as the force is acting away from the point, so components will also act away from point. So nearer to the angle, so it will become S cos theta. Away from the angle, it is S sin theta. Why? Because nearer to the angle, always it is associated with cos term. Opposite side is always associated with sin term, right? So let us apply equations of equilibrium first. The algebraic sum of force components along y direction is equal to 0. So here the forces along vertical direction are N2 acting vertically upwards and weight acting vertically downwards, and then the vertical component of S, which is nothing but S sin theta acting along positive x direction, so plus S sin theta equal to 0. From this, let us subject this equation to N2, which is nothing but W2 minus S sin theta, right? Now let us apply sigma fx is equal to 0. So when we consider sigma fx is equal to 0, we need to represent the horizontal forces. So minus S cos theta, I am representing negative symbol here. Why? Because it is along negative x direction, and plus F2 is equal to 0 minus S cos theta plus F2 is equal to mu N2, we know, right? So instead of N2 I am writing that value, so W2 minus S sin theta equal to 0. So now taking minus S common, cos theta plus mu sin theta plus mu W2 equal to 0. From this we can find the value of S. S is equal to mu W2 divided by cos theta plus mu sin theta. Substitute the values from the given question. Mu is given as 0.3 and W2 is 222.5 Newton, and theta we have got that one is 36.86, right? When you substitute those values, you will get the value of S. So when I simplify this one, I got 68.11 newtons. This is the value of S. Let me calculate the value of N2 by substituting in this relation. So by considering this relation, N2 is equal to W2 value is 222.5 minus S, just now I got that one 68.11 sine 36.86. So if I simplify this one, I will get the value of N2. I got that one as 181.64 newtons. So this is the value of N2. Now let us apply equations of equilibrium for block 1. So I am considering sigma Fy equal to 0, which is nothing but algebraic sum of forces along y direction equal to 0. From that, N1 acting vertically upwards minus N2 acting vertically downwards minus W1 acting vertically downwards equal to 0. From that, N1 is equal to N2 plus W1. Just now I have calculated the value of N2, which is nothing but 181.64, and W1 value is given as 890 newtons. So if I substitute that one, so I will get the value of N1. So I got that value as 1071.64 newtons. This is the value of N1. Let us find the value of P by considering sigma fx is equal to 0. Sigma fx is equal to 0. When I consider sigma fx is equal to 0, P is along positive x direction, and F1, which is nothing but mu N1, is along negative x direction, so negative symbol, minus mu N2 is equal to 0. From that, P is equal to mu common N1 plus N2. I know the values of mu, which is nothing but 0.3. N1 I have got that one is 1071.64, plus N2 is 181.64. So if I substitute these values, I will get the value of P. I got that value as 375.98 newtons. This is the value of P. Hope you like this video. If you like this video, click on like button and don't forget to subscribe.